Hello, everybody. So here we are, law of cosines. So law of cosines, like the law of sines, is true for any angle, but you're not always going to have all the information that you need. So here is triangle ABC, and you've got these three relationships. And there is a lot of order here. It looks like a mess when you first look at it, but there is order. Like let's take this middle one. You've got three sides, A, B, and C. And it starts with the side B on one side and cosine of angle B on the other side. That relationship is true for the other two. Side A ends with cosine A, side C ends with cosine C, etc. And then the others are, when you talk about side B, the other two sides are side A and side C. You've got A squared plus C squared, so you're adding the two squares, and then those two occur again next to the cosine, minus 2 times AC. You're not going to be, you should have this memorized, and you don't have to spend time to memorize it. All you have to do is follow along with the notes that we're doing and do the homework. That will be sufficient in getting this into your brain. Let's play around with a little bit of algebra here. So here is the first relationship, a squared equals b squared plus c squared minus 2bc times the cosine of a. You can represent this in a lot of different ways. I could subtract b squared. We're going to do this a lot here because I just want you to get comfortable with seeing things that look different but are really the same. Those two sentences are the same. They're telling you the exact same thing. They just look different. You could subtract c squared. I could divide both sides by a negative. So I have negative a squared plus b squared plus c squared equals positive 2bc cosine a. I could divide both sides by 2bc. All these equations are the same. They're all the same. They just look different. First of all, let me start off with b squared plus c squared minus a squared. And I'll divide this all by 2bc, and that equals cosine a. I hope you're seeing that I just took this equation and I divided both sides by 2bc. And, well, I can take the cosine inverse of that, can't I? Cosine inverse. So I'm about to rearrange the domain and the range. So that's an inverse property. Cosine inverse of this monster, b squared plus c squared minus a squared all over 2bc, is the same thing as angle A. I mean, they're all law of cosines, and we should be pretty adept at just multiplying, dividing, subtracting on both sides of the equation and realizing that we have the same situation, just represented differently. I mean, in Algebra 1, this is the slope-intercept form, but I could write that as y minus b equals mx. So let's put this into practice. First of all, I should mention that we're only going to solve two triangles, side, 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 or side, angle, side. And in these two situations, you don't have the opposing relationship. You don't have an angle and its opposing side, so you can't do law of sines. We would almost always choose to do law of sines because it's less work. But in some cases, we have to do law of cosines. Now, to solve means to find all three angles and all three sides. And what do I have? I have one angle measure and the two other sides. I don't have the opposing side. I don't have side A. So I'm forced to do law of cosines. Now, which one of those three iterations has side C, side B, angle A? Which one has side B, side C, and angle A? Side B, side C, and angle A. It looks like this first one. So I'm kind of forced to, the decision's already made. I really just have to do this one. I don't have enough information for that one. I don't have enough information for that one. I have side B, side C, and angle A. So you want this memorized? Write it out. A squared equals B squared plus C squared minus 2 times B times C times the cosine of A. Now plug in the knowns. I don't know A, but B is 13 squared. C is 9 squared minus 2 times 13 times 9 times the cosine of 71 degrees. Now, I have a huge advantage. This is all just one number. I mean, there are several numbers there, but after I add and subtract and multiply everything, it just boils down to one number. So I'm going to do myself a favor and just put everything that I see right here. I'm just going to put it into my calculator exactly as I see it. 13 squared plus 9 squared minus 2 times 13 times 9 times the cosine of 71. Enter, and I get 173.817 square root both sides. And mathematically, you would take the plus or minus since you're square rooting, but we had to remember the big picture. We're in a triangle, so triangles are not going to have a negative side. So just positive 13.184. That is side A. 13.184. Whoops. So we're 4/6 of the way done. Now I have that opposing relationship. I've got an angle and its opposing side. So I'm going to use law of sines now, but we got a trig tip. After you've done law of cosines, you're going to use law of sines, but you're going to find the smaller angle first. The smaller angle first. I need to find angle B. I need to find angle C. Which one of those two is smaller? Angle C, because its opposing side is 9, which is smaller than 13. So I'm going to find angle C first. Pay attention to the trig tip. After you've done law of cosines, you're going to do law of sines, and you're going to find the smaller angle first. So here's my law of sines work. I have this opposite relationship, sine of 71 over 13.184, and I'm going to set that equal to the sine of C over 9. 9 times the sine of 71 equals 13.184 times the sine of C. Divide. So 9 times the sine of 71 equals 8.5. Divide that by 13.184, and I get 0.645 about. So that's sine of C. Sine inverse that. And I get about 40 degrees. About. Now, with the reason why you want to do that is because it avoids the ambiguous case. Because if you look at the unit circle, here's 40 degrees is there's 40 degrees. It has this particular sine value of 0.645. That's the y value. But so does this angle over here, which is 140 degrees. 140 degrees also has a sine of 0.645, but 140 degrees would have to be rejected because we know the triangle has 71 degrees, and adding 140 would breach 180 degrees. So that's the advantage of using this trig tip. We want to avoid that. And then finally, we're almost done. We have to find all three sides and all three angles. So I just need to find one more angle. So now I really don't have a choice. I'm going to do sine again, law of sines again. Sine of angle B over 13. Oh, what? No. Wait. Triangles of 180 degrees. What am I? Come on. One of those angles is 71 degrees. One of those angles is 40 degrees. So I just subtract to get 69 degrees. And the triangle is solved. Let's try again. Solve this triangle. Solve the triangle. Find all three angles and all three sides, and I've got all three sides. So I just need to find all three angles. Here's another trig tip. If you're ever faced with side, 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 you always want to find the angle, the biggest angle first, which is always opposite the biggest side, which is angle 6. So I want to find angle B first. So back to the law of cosines. Which one of these is going to help me find angle B? There's only one that has angle B. It's the one that starts off with side B squared. So that's the one I'm using. B squared equals a squared plus c squared minus 2ac cosine B. So B squared, write it down first, then it'll just internalize, equals a squared plus c squared minus 2ac cosine of B. Plug in the numbers. B squared is 6 squared equals 1 squared plus 4 squared minus 2 times 1 times 4 times the cosine of B. Now, this is another one of those times in math class, in this class, where you want to slow down and totally realize everything you're doing, because lots of people make mistakes here with the order of operations, and you cannot afford to do that. Order of operations needs to be totally mastered. You're adding these two things, and you're minusing this whole thing. They're not like terms. So you're never going to combine those things, never. I got 36 equals 1 plus 16 minus 8 cosine B. 1 plus 16 is 17. And the problem, this is kind of moot of me to say because the people who usually do this aren't listening right now. People want to combine these two things. That's totally illegal. They're not like terms. So you cannot combine them. One has a cosine, the other one doesn't. What you can do is subtract 17 on both sides. So 36 minus 17 is 19. And now you would divide both sides by negative 8. And that gives you negative 2.375. And now you need to know that there is no such triangle, because cosine can only produce values between negative 1 and 1, and therefore it'll never be negative 2. Never, 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 never. And in fact, if I gave you a stick that was 1 foot long, another stick that was 6 feet long, and a third stick that was 4 feet long, you will never be able to create a triangle. Never. Unless the sticks are overlapping. You can't have a triangle with those three measurements. Last one. Find one angle in the triangle given these three sides. Again, we have side, side, side. Don't forget your trick tip. If you ever have side, 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 you got to find the longest side first, which in this case is side B again. So I'm using B squared. Write this down so you internalize it. Equals a squared plus c squared minus 2ac times the cosine of B. Now let's plug in those numbers. 7.6 squared, that's going to be fun, equals 3.2 squared plus 6.4 squared minus 2 times a times c times the cosine of B. All right, calculator, 7.6 squared, 57.76 equals, I'm just going to add these two up in my calculator. I don't want to write down all this stuff. Plus 6.4 squared is 51.2 minus 2 times 3.2 times 6.4 is 40.96 cosine B. Remember, guys, I'm telling you, the mistake is this. You've got one term there and one term there. They're not like terms. You cannot subtract them unless you think this equals 2x. In that case, you're in the wrong class. These two are not like terms. You cannot combine them. These two are not like terms, so you cannot combine them. What you can do, because you got an equal sign, is you could subtract 51.2 on both sides. So 57.76 minus 51.2 is about 6.56 equals, don't forget the negative, 40.96 cosine B. Divide by negative 40.96, and you get negative 0.160156 is about cosine B. Cosine inverse. And you discover that B is about 99 degrees. Law of cosines.